Welcome back to Programming Logic and Design. In this chapter, we'll be discussing the elements of high-quality programs. In this section, we'll be discussing declaring and using variables and constants, and a very important feature in programming. I need to remind you guys what a variable is. A variable is a value assigned to a variable. Okay, that's any value. So if you have a look here, it is a box of memory in our computer where we're going to be storing contents into the box. In this case, we're storing our value 16 into the box, and this box's name is num1. And this box here, his name is num2, and we are storing 4 into the contents. So this is our representation of a variable in memory and how it's actually used in our computer program. To discuss data types, we need to discuss data items. And data items is what we put into our computer. We put into computer using our keyboard or mouse, etc., etc. And we store it, remember, in a box of memory in our variables. So whatever our variables names are, that is what we are allocating memory space for whatever data items we put in there. Remember, it goes into the box. Alright, so that is converted inside our computer and is outputted onto our screen as information. So we get two types of data types. We get numeric and we get string. Numeric is basically numbers, 1, 2, 3, 4, 5, and string is anything not used in maths, like your characters, your $sign, etc. Those are all strings. Now, your different forms, we get integers and we get floating points. Integers are great for natural numbers, so 1, 2, 5, 7, etc., etc., etc. Even 0. It's good for that. But it is not good for when we have a fraction. And for when we have a fraction is basically when we have a 5 divided by 7, which is going to be equal to a real number, which is going to be equal to a fraction with decimal points. That is where floating point comes in. It is basically a fraction that contains decimal points, and it can store real numbers for us. Then we get our literal and string constants. Literal numeric constants is when you use the number, say, 43 directly within the program, and it's got no quotation marks on it. A string constant, on the other hand, a literal string constant will be a specific text, so such as a man. Duh. So that will be your literal string constant, and it appears within quotation marks in the program. You get another type of string constant, which is called an alphanumeric. Now, alphanumeric will be alphabets and numbers mixed together, and they will be in double quotation marks too. So let's say the $sign 3215.99, and that will be your US Canadian dollars. So they'll probably use this for like tax purposes and tax program. Then you get your unnamed constants. Your unnamed constants will be 43, will be Amanda. They do not have identifiers like variables do. Now you ask, what is an identifier? An identifier is a variable's name. Variables are named memory locations, and their contents can vary or differ over time. An identifier is your variable's name. It's what you've named your little box of memory. Let's say this was your num1. Num1 will be your identifier because it's your variable's name, and your box which you've created is your variable. So that will be your variable. Declaration is a statement that provides a data type and an identifier for a variable. So let's say we want to create an int. So in this case, if you were doing Java, it will be int num1, and this entire statement here will be your declaration. Now, for purposes in this course, we won't be using int. We will be using just simply num1. So num will tell us that we are working with a number, and we need to create a data type of num. Let's just revise the number doubling program from chapter 1. We start our program, we input my number, we set my answer equal to my number multiplied by 2, and we output my answer, and then we stop our program. Now, I've just told you that we need to declare our data type and our identifier for our variables. And our variables in this example is my number and my answer. So we need to declare those two. All right, so data type. What is data type? Data type is the classification that describes what the values can be held by the item, how the item is stored in computer memory, and what operations can be performed on the data item. So we can't use a string, declare a variable a string, if it is, so let's say we've declared this box of memory a string. Now we can't use this 9 in a multiplication, in an arithmetic formula, because it's declared as a string. You can't use this box of memory, this variable, as an arithmetic sum. Now, in some programs, it is very important to initialize the variable. When I talk about initializing the variable, you're declaring a starting value for any variable. So let's say we declare my number is equal to 0. The reason why we need to initialize my number is we do not want to have a variable containing garbage. A garbage value which can result in a logical error. Now, what is garbage? Garbage is pretty exactly what it says. Garbage is a variable's unknown value before initializing. So what's actually happening is if you do not declare a variable and if you declare a variable and you do not initialize the variable, that variable contains unknown value until it is assigned a value by the user. Now, the garbage is also data that has been placed in a random access memory space, which is obtained from the operating system, that is no longer needed. And also what happens is when you've got garbage is that it's freeing the space for reuse, so you actually garbage collecting into your variables. So you don't want the computer to randomly put, let's say, a 2 in there if you haven't initialized it, and you think, oh no, there is nothing in there, and you try and do a sum, it will be with 2, and then what's going to happen is you're going to have incorrect output eventually at the end of your program. That is why I said you're going to have a logical error. Now you're probably asking, why do we need to know all this? In the past, programmers actually had to write programs that explicitly requested storage and then returned it to the system when it was no longer needed. So basically, programs that neglected to return unused storage actually can be shut down by the operating system. In other words, your program could crash. The term garbage collecting apparently was first used in the Lisp programming language. Java is a newer programming language, but like Lisp, handles garbage collecting for the program and freeing the programmer from being concerned about it. Another benefit of Java. So how do we declare our variables? Let's have a look go back to our number doubling program. You'll see you will write declarations and you will declare everything under declarations. So here we're declaring my number as num, my answer as num. We're not initializing here, we are just declaring because we're going to assume that an unassigned variable holds garbage. So this over here, because we have not assigned it, in our memory it's probably got 75 in it. And my answer has probably got 242. So we don't know what's in there. Probably if you output my number without inputting anything, you'll probably see that it will come out as garbage, whatever your operating system throws into that garbage variable. So whatever's been in your memory space will be thrown at it, or your program will shut down. So now we know how to declare our variables. Naming our variables is another very important thing. Programmers choose reasonable and descriptive names for their variables. Programming languages have rules for creating identifiers. Most languages allow letters and digits. Some languages allow hyphens. And reserved keywords are not allowed. Reserved keywords, depending on what programming language you're using, you will have a keyword list. So for Java, you will have a keyword list. Those reserved keywords are not allowed in your variable's name. And variable names are case sensitive. I'll go more into casing just now. But just want to point out that each computer programming language has its own rules about variable naming. However, there are common rules that should be applied, which is listed on pages 42 and 43 of your textbook. Also, programmers use multiple conventions for naming programmings, and it's often depending on the programming language, as said, or standards implemented by your employees. So when you start working for somebody, they will have their own standards for naming variables in their programs. Now, we've spoken about my number. Is my number reasonable and is it descriptive? Not really. You could rather use, instead of saying my number, you could use user entry, because you can see that they're going to input my number. So user entry, it's more descriptive, it's more reasonable. Or input value would also be more descriptive and more reasonable for our number doubling program. Also, let's say my answer. My answer isn't very descriptive, so we could rather use program solution. Or we could use twice the value, which is also very descriptive. Right, we get three types of casings or notations. Common conventions include, firstly, our camel casing, which is our variable names such as hourly wage have a hump in the middle. So it goes lowercase, uppercase, lowercase. So the next word will be uppercase, start with an uppercase, and it's all one word, please note. So the hump will be in the middle. Then we get Pascal casing. This variable's name, such as hourly wage, the first letter of the variable is uppercase. The next one is Hungarian notation. Hungarian notation is variable's data type is part of the identifier. Example, num hourly wage or string last name. Or I hourly wage, which is integer hourly wage, or string last name. You need to adopt a naming convention for variables, use it consistently, which helps make your programmers easier to read and understand. All right, let's go through this live example. Say tomorrow someone came to you and said a fellow developer is unable to complete a critical piece of code, and you're the only person who has the skills and knowledge to finish the job. And by the way, you only have until the end of the week to complete the task. Otherwise, the customer will cancel the contract and take that six-figure sum elsewhere. Before you panic, you decide to evaluate the situation by reading the sample of code. You need to find out whether it looks reliable and whether you can understand it well enough to modify it. Which of the three conventions would best fit this scenario? Would it be camel casing? Would it be your Pascal casing? Or would it be your Hungarian notation? So, Hungarian notation gives you the data types. Pascal casing just is Pascal casing, and camel casing is just basically the way you write it. So which one would it be? Remember, it is only a piece of code. Yep, you guessed it right. It would be your Hungarian notation. So, therefore, be super descriptive, must be one word, must start with a letter, and should have some appropriate meaning, please. Right, we're going to identify whether these variables are correct and explain why not they're not correct. So let's have a look at the variable 1. Here is pay rate. Is this correct or incorrect? It is incorrect. Why is it incorrect? Because there is a space there. You should actually have this as pay rate. Now, dollar amount. Is this variable correct or incorrect? It is incorrect. Reason being that it has to start with a letter, not a character. So if you wanted to put dollar, you will just have to put dollar at the end. B1. Is that correct or incorrect? It is correct, but not a good idea because it is unlikely to have any real meaning. So you're going to have to give it more. That sign means give more. Movie title, correct or incorrect? Correct, but does not adhere to camel case standards. So reason why I'm saying camel casing is that in this course you have to do camel casing, because the reason being I say camel casing is that majority of your employees do camel casing. So that is why I want you guys to do camel casing now, so that when you do work for somebody one day, it's already ingrained in you. Now, question 5 is 10 best incorrect or correct? It's incorrect because it should start with a Alright, so let's have a look at asterisk. Is asterisk correct for a variable name or incorrect? Incorrect, because it represents multiplication. Variable? Ah, this one's a bit tricky, hey? It's correct, although it would seem not to be correct. Variable is not a keyword in programming. Look at name. Well, variable name would be correct, but it depends on the language you are programming in. So I know name can be in a good springboard of keywords. Supercalifragilisticexpialidocious. I think this word actually might violate the length rules of our variable naming. Garbage. Also a trick. It is correct, and programmers actually do use this variable name. Finally, now I can introduce you to our assignment statement, how to correctly say it. Our assignment statement is my number multiplied by 2, which is stored into my answer. So we're setting my answer to be my number multiplied by 2. This is our assignment operator. It is an equal sign, and it always operates from right, which is here, to left. So valid will be set some number to be 2. So we're taking 2 and we're setting it to be into some number. Some number we are setting into some other number. Not valid will be set 2 plus 4 equal to some number. This is not valid. It should be the other way around. So our assignment statement completes 2 actions. From right calculation, which is here, to our left storing calculation in memory, which is our named storage allocation. Now, why do we use the word set for assignment statements in pseudocode and flowcharts? Reason being is we use set is because it emphasizes that the left side value is being set. Just a quick summary of numeric values and string values. Numeric values hold digits and can perform mathematical operations on it. String variables can hold text, letters of the alphabet, special characters such as punctuation marks. Using programs like spreadsheets or databases may have introduced you to the fact that computers handle string data differently than numeric data. Now, students struggle with data types such as telephone numbers and zip codes because the data consists of all numbers. Now, students want to make those variable numbers. A good rule of thumb is that something is a number only if it can do math with it. For example, we would not want to multiply your zip code by another zip code and see where it gets us. In exam type questions and in your tests, they love to ask you telephone numbers and zip codes just to make sure that you actually understand that zip codes and telephone numbers are not numbers. They are going to be stored as strings. Now, type safety prevents assigning values of an incorrect data type. So you cannot assign monitor, let me write monitor, to a tax rate, numeric value, and 2.5 to an inventory item string variable. You have to assign the correct data type for each variable and use it appropriately. Example, you cannot sum up a list of names that have been assigned string memory storage. Alright, we get our named constants and our magic number. Named constants is similar to a variable, but it can be assigned a value only once, which is usually at the beginning of your program. You assign a useful name to a value which will never be changed during the program's execution. A magic number is an unnamed constant. So if you use tax amount equal to price times sales tax amount instead of tax amount equal to price times 0.06. So what is my magic number? My magic number here is 0.6, and my named constant is my sales tax amount. See, it's separated by underscores for different words, and it's all in uppercase. Very important. Reason why we do it like this is that it's easier to recognize. What are the benefits of declaring a named constant? Maintenance becomes so much easier because if you think about the tax amount, this year it might be 6%, but next year it will be 8%. So if you had written and magic numbers through the entire program, and believe you me, you will have thousands of lines of code, you will have to go through your entire program and change that 0.06 to 0.08, and let's say it got a 2% increase for next year. It is really cumbersome. Would be much easier right at the beginning of your program, where you declared sales tax amount is 0.06, you would just include that in there. You will just change it right at the beginning of your program. Please join me for the next video in which we'll be discussing performing arithmetic operations.